In Lab 5 of Introduction to Computer Architecture, we are to write a program that prompts the user for 3 integers. We then take these 3 integers and store them, and then multiply them by a set value. After we do that, we are going to add all of the values together and print out this value, and then we have to divide. So the main focus on this lab is being able to properly store things and then divide them, as well as multiply them and then output these integers. So the first thing that we need to do is have our comments right here that tell the lab title, our name, and how to assemble it, which is AS for assemble, -O, lab 5.0, and lab 5.asm. We then have to link it by doing ld-o, a.out, lab 5.0, and CSC 35.0, then execute it by doing /a.out. And we do this all in the main console when we execute from our nano. After we have this, we can start writing our code. And the first thing that we need to do is state that we're going to be using the Intel syntax. And to do this, we need to do .intel_syntax, no prefix. After we have this, we can do .data, because we are in our .data section. Later, we are going to need a .text section, so we can just create this now by doing .text. We want to have a start, but we need to make this global, so we'll do .global space_start, and then we'll have an underscore start right after it with a colon. In our text section is where we're going to be doing most of our program, and our .data section is just going to have titles. So the first thing that we're asked for in our rubric is for a menu. And this menu basically just prints out pumpkin pastry, 16 grams, flagon of butterbeer, 21 grams, and tower of ice cream is just 40 grams. And then we have a /n, which is basically a new line separating all of these. We do this all in one label just to save labeling and space, so we don't have to call multiple labels. When we're just separating these by /n's. We're doing 2 /n's right here to give it an extra spacing, and then we are doing a /0 to end this string. And this is asked for in the rubric. Then we have 3 questions, and we need to have these 3 questions so that we can get 3 integers of user input and then manipulate them. After we have these 3 questions, we can go into our .text section, and in our .text section, we need to first print out the menu. We do this by loading the menu into RAX and then calling the print C-string to print it out. After we have this, we want to call our first question. So we'll do the same thing where we load our first question into RAX and then use the call print C-string to print it out. After this, we want to get user input. So we are going to call scanInt. And once we call scanInt, then this allows the user to type an integer. After they type this integer, we want to manipulate it. To manipulate it, we are going to multiply that value by 16. And for question 1, we're going to multiply it by 21. And question 2, we're going to multiply it by 40. So question 1, how many pumpkin pastries is multiplied by how many pumpkin pastries of grams at 16. Same thing with this one, where it's butterbeer being multiplied by 21 grams, and the input for ice cream is being multiplied by 40 grams. So after we call scanInt, we have to use the assembly multiplication. And this is going to be IMUL for I multiply. And then we're going to do I multiply RAX, which is currently where our scanInt is, and we're multiplying it by 16. After we have this, we want to add it so that we have a total amount of grams of sugar. So we can go back up to our .data section and make a new label, and we can call it grams. And this will be a .quad, and we'll initialize it to 0 since we're adding into it. And we can go back down here underneath I multiply, and then we can say add into grams RAX. Basically, an overview of this is that we are printing out our question 0, we are calling scanInt to get user input, and we are multiplying the scanned integer by 16, and then we are putting the multiplied value into grams. We are adding it in. And we're going to do these for question 1 as well as question 2. The same thing, the only thing that's really going to be changing is this value here. I've done the same thing for questions 1 and question 2 as I did with question 0. Only thing changing is the actual question itself. This has to be question 0, this is the next question, question 1, and this is the next question, question 2. These also changes because we are multiplying it by different values, and then we are just adding all of it into grams, so we keep adding it to each other. After we do this, we need to print out how many grams of sugar we have. So we're going to go back up to our .data section because we need to have a string. Under our grams, we will do sugar1 because this is going to be 2 parts of a string. And we're going to do .ascii, that's, and then we need a space after the s, and then a /0 to end this. And then we're going to have sugar2, and in our sugar2 we're going to have .ascii grams of sugar with a /n after a exclamation mark and then a /0. Basically what this is saying is that we are going to print this part, that's grams of sugar. And between that's and grams, we are going to have a number. And that number is going to be all of our grams printed out. After we add all these grams, we're just going to print it out between our sugar1 and sugar2. To do this, we first have to call them. So we're going to do load effective address into RAX sugar1. So this loads that. And then we need to call print cstring to actually print it. And then we need to move into RAX grams. So whatever is in grams, whatever values is stored in grams is going to be moved into RAX. And the reason we need to do this is because we need to call print int to print out this integer. And then we are going to do the same thing where we load the effective address of RAX of sugar2, and then we call print cstring. So first right here, we're going to load the effective address of sugar1 into RAX and then print it. So we're printing out that. And then after this, we are moving whatever value is in grams into RAX, and then we are printing that integer. And then we are loading the effective address of sugar2 into RAX and printing that. So we're going to have that's whatever is in grams of sugar. After we have this, we need to prompt the user for how much sugar each student can have. So we're going to go back up to our data section, and we are going to make a new label, and we're going to call this max sugar. We're going to have .ascii with our prompt inside of here, which is how much sugar can the student have. And then we need a /n for a new line and /0 to end it. We're going to go back down here, and we are going to do a load effective address into RAX max sugar, and then we are going to print out our question by using call print cstring. And then we need to get the user input. So the user is actually inputting how much the max sugar is. So we are going to do call scan int to get this integer, and then we need to store this value. So we need to go back up to our .data section and make a .quad for it. So underneath max sugar, we are going to have max as our label, and then we'll just do .quad space 0. So this stores our max sugar. We're going to go back down here, and we are going to move into max RAX. After this, we're basically going to divide our max by how many grams we have. And we are going to do the same thing as we did in sugar1 and sugar2, where we have different parts of a string. So we're going to be back in our .data section, and we can call this end1 as our first label, and to have a .ascii with this in it, the student can only eat this, and then a space and /0 to end this. And then we will have an end2, where in here we'll have a .ascii times period with a /0, and then a space right in front of times just to separate this. And basically we're going to print our first end1, and then we are going to print our second end2. But in between these, we are going to have the number. And this number is going to be our max divided by our grams. So we need to use a division method. And we can do this by making another part right here and loading the effective address of our end1 into RAX, and then calling the print cstring to print it out. After this, we need to do our division. And to do our division, we need to move the value of our grams into RAX, and then we need to move our max into our RBX. This is important to where they go because whatever is in RBX is going to be the denominator of our division. So we will move into RAX our max because our max is our numerator. So whatever is in RAX is our numerator. And then below this, we are going to move into RBX our denominator, which is grams. So currently RAX stores max, and then RBX stores grams. And now we need to use the division. And to use division, we are going to have to preface this with a CQO. And our CQO stands for convert quad oct, and we need this before our I division. Our division is almost like our multiplication, where in our multiplication we have IMUL, but here we're going to have IDIV. And then in here we are going to write out RBX. So we are dividing RAX by RBX, and we state that here like this, because our denominator needs to be next to our I division. This is just math, it's not printing anything, but we do want to print this number. So we are going to call print int, and this will print the integer value of RAX. When we divide, RAX is our quotient and RDX is our remainder. So if we wanted to print our remainder, we would have to print RDX. However, since we are printing RAX, all we need to do is call this, because call print int prints from RAX. I wrote this in a comment right here. We're looking for our quotient. We need the quotient, and we are going to use this value, not the remainder. After we have call print int, which prints the value, we just need to get the last part of our ending statement, because we split this up right here. The student can only eat this, and then we have our number, and then we have time. So we need to call n2. And the way to do this is just by doing a LEA, load effective address, of n2 into RAX, and then calling print cstring. That way we can print it out. And after this, we've finished. So we can just call end program. If we exit this by doing Control X, Y, and enter, we will be in this terminal. So to run this, we need to do assemble, which is as-o lab5.o lab5.asm, and then if we press enter, we have no errors because nothing has popped up on our screen. So we continue with linking it. We do link that -o lab. For lab, we need to do a.out, and then we can do lab5.o, and then csc35.o. So we link a.out, lab5.o, and then csc35.o. Press enter. We have no errors, so we can do ./a.out and run it. We have our menu that pops up right here, and then our first question. We're going to press in 4 for here, 3 here, and then 2 here. It tells us that there are 207 grams of sugar. We should have an extra space between these, and we can fix this after we test run this. And then now it's asking how much sugar can each student have. We'll put in 700, and it says the student can only eat this 3 times. This is correct. If we want to fix our spacing errors, which is right here and right here, we can go back in our code by doing nano lab5.asm, or nano and then whatever the title is. So going back in here, we know that we need a space after our sugar line, which is this. So we'll just have another /n here, and then we need a /n after our ending. So we'll go into our n2 and do /end. This is a great time to look over our program. So this is just our preface for our program, telling what it's going to do, how to assemble, link, and execute it. After this, we are in our .data section with the Intel syntax. Then we have our menu here, our 3 questions, and then our storage for grams. And then we have our sugar statement. We have our max sugar statement, as well as a .quad, which stores the maximum sugar that the user inputs. And then we have end1 and end2, which is the same thing as sugar 1, sugar 2, except unlike in sugar 1 and sugar 2, we are going to be dividing. Sugar 1 and sugar 2 is multiplication focused. Technically, the multiplication happens with question 0, 1, and 2, but sugar 1 and sugar 2 actually prints out this multiplicated value. If we go into our .text section, we print out our menu here, and then print out our first question, calling scanInt to get user input, and then multiplying this by the value we have in our menu, and then adding it to grams. We do the same thing for questions 1 and question 2 that we did to question 0. Then we are going to print out the first part of our sugar. We are going to print how many grams is totaled, and then we're going to print out our second part. Then we are going to ask the user what is the max sugar each person can have. We're going to get this value and store it into max. After we do this, we are going to do our division right here. So we call the first part of our ending, we move max into RAX, and then we move grams into RBX. This is part of our division, and then we preface our actual division with a CQO. And then we do IDIV, RBX, because RBX, which is the denominator, needs to be right behind IDIV. And if we want to print out the quotient, we would use RAX. If we want to print out the remainder, we use RDX. We're going to call printInt to print this out, and then we finish off our ending by calling print cstring for the second part of our ending, and then ending our program. If we exit this, I cleared it, and we can run this again. So we're just going to do an assembly, a link, and an a.out. We have our menu and our question. We'll do 5 for this, 4 for this, and 3 for this. This is 284 grams of sugar. If we wanted to, we could pull up a calculator and calculate this. We would do 5 times 16 plus 21 times 4 plus 3 times 40. If we do this, we get 284, which is correct right here. How much sugar can each student have? And then if we were to put 900 in here, we can say that the student can eat this 3 times, because 284 times 3 gives us 852, and we cannot exceed this value. If we wanted to go crazy and do some bigger numbers, we can do 1, 3, 6. That is the correct value. How much sugar can each student have? We can say 9,000, and we can see that the student eats this 28 times. Again, if we plug this into a calculator, we would see that it is correct. And so that was the code and solution to Lab 5 of the Introduction to Computer Architecture.